Alright, we're going to look at a situation here where we can draw an x versus t graph. For this situation, we have Blue leaves Pallet Town after receiving the best starting Pokemon ever. Hold on a second, we need some visual representation. There we go. Now we can see the best Pokemon ever. He leaves from rest and begins walking down the path when he thinks that he forgot some Pokeballs. So he pauses a moment to think about it, and then heads back towards town. Upon getting part of the way back, he realizes that he did in fact pack them, and so he stops again. We'll start time a moment before he leaves town, then end time after he realizes he remembered them. So what I'm going to do here is I'm going to start by drawing a picture. Okay, here we go. Let's go. We are walking down the road. All right. He's going to walk away from Pallet Town here. Pallet Town. Head this direction. Upon getting here, he's going to stop and reflect. Then he's going to come back. And he's going to remember right about here that in fact he did remember him, and that's where we stop time. So using this very, very quick and crude drawing, I can see, of course, that he's not going to get past the original spot. Now, at the beginning of all problems, of course, we have to establish a zero. If left to our own devices, it's usually easiest to start zero, of course, right where he left. And we also have to choose positive or negative. Again, easiest positive is to go in the direction that he starts here. So, here we go. Draw a fairly large T there, just in case we need it. Alright, so I'm going to start here at 0, which means I start right here. It also points out that he starts from rest. Because of that, that's not why we started at 0. We started at 0 because his position was 0. Because it starts at rest, we need to make sure that the line is horizontal to begin with. Now, the moment he's at rest, he's going to begin picking up speed. So let's do this. Let's look at this, the first small time segment right here. So he's just going to curve up here in a parabola when he's accelerating. Okay? So this small thing here, you can see I kind of try to start horizontally here, and then I come up to a speed. Okay? And he's going to start during this particular time segment here, which is quite a ways. Okay? He is going to be traveling at a constant velocity because that's what everyone does. They walk to it, they get to a speed, and then they stay at that speed. Okay? So we're going to have a constant velocity for that time segment as best as I can. Now that should probably go longer than that, but I'm going to stop it here. So that's going to be until he has to slow down again right about that spot right there. Okay, so for this time segment, we'll call that T1 there to T2. During that time segment, he was traveling at a constant velocity. From T0 to T1, he was accelerating. Now, let's look after T2. He is going to slow to a stop. He's going to slow to a stop because that's when he figures out that he forgot the Pokeball. So here he goes. He's going to go to a, I'm going to try to make, that should be a parabola there. Okay, and that's T3. Now I got him to a stop here. It also says that he pauses for a moment, so he stops for a little while to stay at the same spot. So that's where right here, T3 to T4, he's at this location right over to here. Okay, he's just stopped right there. Now he decides to go back to town in order to figure out, so right here, we're now in this path right here, he decides to go back to town in order to find them. So he's at rest, so first he's got to get back up to speed. So there we go, another parabola going down this time because he's going to pick up speed going the negative direction. Alright, so now he's going to find a constant velocity. And I should probably stop right here because he does not make it back to town. He doesn't make it back to the 0. So this line right here represents the 0 position, which he doesn't make it back to. So at T6, this is where he decides, I'm sorry, where am I at here? He decides that he does, in fact, have the Pokeballs because he packed them. And so he's going to stop again. So he's going to come right back here to T7. In these problems, you'll notice it's pretty specific, somewhere in the problem telling you exactly when to begin time and exactly when to end it. In this case, it says we're going to start time the moment he leaves town. That's why we need to start here. And it's going to end time after he remembers the Pokeballs, or at T7 once he's already stopped. Alright, so I just redrew all the same situation for 3 different times. Okay. First of all, I want to apologize about kind of the quality of this. I'm not terribly exact with this technology right now. Anytime this curves right here, there should be an acceleration. It should, if I draw it correctly, be parabolic. And these should be straight lines. They should, in fact, be linear if I'm not, messing up on this. So let's look at this in two different ways. What I did here is you'll notice this is flipped from the first one that we did. My 0 is still Pallet Town. Okay, I'm still starting from rest, but the only difference about this particular situation is I decided that the original direction that I'm going in is going to be negative. So that's why it looks entirely flipped, because everything is exactly the same. This is when he's speeding up, going that way, going the negative way. This is when he stays at a constant speed along that first path. This is when he slows down to a stop to consider the Pokeballs, stays stopped, then accelerates back to try to go back to town, stays at a constant speed, and then stops once again. I've even got the same T1, T2, T3, and all of them on here to match up with the one before. So this is when Pallet Town going negative. All right? So that's a positive, negative switch. This situation looks almost identical to the original situation. The only difference here is I've moved where the original 0 was. In this particular case, the 0 is where I stopped. So this was situation 1. This is situation 2 here. All right. So this is where I stopped. So I start back in Pallet Town. Since the 0 is here, that means I'm starting negative. So I accelerate negative. I go, from the negative. I'm still going in the positive direction, but I'm in the negative position. So I pick up speed in a constant speed. This is when I cross that spot the first time. Then I'm right over here, slowing down, staying stopped. Then I decide to turn back around, or he decides to turn back around. It's a constant speed. Then you'll notice stops at that 0 right here. So this is when the 0 moves. Move. All right. And the final situation here is I'm the same exact as the beginning. 0 is at the beginning. Positive is the correct direction. The only difference is I've started time, you'll notice, at T1 when he's already moving. So he doesn't accelerate in this case. A lot of your drawings will start the same way because the objects start with an initial velocity. Now, technically, right back over here is negative time, or this is the time before we started measuring. This is where our T0 was to begin with, and there should be kind of, if I can do it, a dotted line right in here to represent this initial acceleration. You would draw this if this problem had asked you to start time after he's already up to speed. And then you would begin, he's already up to speed, again slows down, stops for a moment to consider, goes back, accelerates the other way. This should be a constant here as he heads back to this spot right there, and then slows down to a stop when he realizes I've got my Pokeballs. So that's how you do that.